calculator with parentheses, just like this. Put the 2 in the parentheses. You should get 9/8.
Wait, I put the 2 outside.
But it still got it? Yeah, it'll calculate it.
What? I screwed up.
Okay, moving on. Looking at this, guys, most common error. All that stuff's raised to the -2 power, right? You guys should be following me.
Yep.
So we have 2 to the -2 and x to the -2, right?
Yeah.
So now, because they're both negative exponents, we're going to flip them over a fraction. So we draw our line, we grab this, flip it over a fraction, because it has a negative exponent. Grab this, flip it over a fraction, because it has a negative exponent. Left on top isn't nothing, it's a 1. We have a 1 on top, 2 squared on bottom, x squared on bottom. When you flip them, they're not negative, right?
Can you use the parentheses? X parentheses square?
Yep, actually you could have flipped them since they're both under. Yep, it would have come out to be the same.
Wait.
I thought you were asking
For
me.
the answer, could you like do
Oh.
2x parentheses squared?
Yes. Yep. So then we would actually distribute it through to this, right? Because we were going to simplify further. Good question. So we would have 1 over 4x squared. Does everybody understand how I got 4? 2 squared's 4. Are we all good with that problem? Okay, couple more, and then I'm just going to let you work the rest of the time. Here we go. X squared raised to the -3. Let's sing our song. If this song only works if you have the same base, right? Same base. Okay, ready? When you multiply, when you divide, then you subtract. Raise a power to a power, and you multiply. Now, you multiply the powers, and when you divide, you subtract. You always subtract the top exponent from the bottom, right? Everybody?
Yeah.
This is raising a power to a power, right? So we multiply. X to the -6. Okay, everybody good with that? Not finished. Flip it over a fraction. There's a 1 on top, x to the 6. Is everybody good? Okay. Some people cannot do this for some reason today. First hour. Okay, we have all this stuff. Now, here's the most important thing. So everybody hear me out. The first thing you always take care of is any powers being raised to more powers. Is this stuff being raised to another power? No. Is this stuff being raised to that power?
Yes.
So you're distributing that 3 through to each of those, right? Raising a power to a power, we multiply. So we have x to the 6 and y to the -6, right?
Mm-hmm.
And then we just have this, x to the first, y to the -3, right? Does everybody see, though, how you have to take care of the powers being raised to more powers first? Okay. Now, when you multiply the same base, you add your exponents. Aren't we just multiplying all this stuff? So x to the first times x to the 6. You add them. Add is x to the... And then y to the -3 times y to the -6. When you multiply the same base, you add your exponents. -3 plus -6. Y to the -9. Now you're not done. Flip anything with a negative exponent. So we got to fix that y to the -9. Draw your line. This is what comes down. X to the 7th doesn't. So that's on top. Left is y to the +9 on bottom.
Don't you add them instead of times?
Good question.
Not up top.
Oh. No, raising a power to a power and you multiply. For this piece. Good question. Okay, let's look at this next one. We're almost done, guys, and I'm just going to let you work the rest of the time. It's really going to help, though. We have these, nothing to do with these. But isn't all that stuff being raised to the 1/2 power?
Yes.
So raising both of those to the 1/2 power, you'll multiply, right? Raise the power to a power and you multiply. So you have x, 1 times 1/2. X to the 1/2. 2 times 1/2 is 1. So b to the first. That's a hideous b, but it's okay. And then we have x to the 1/2, b to the 0.
Okay.
Now when you multiply the same base, you add your exponents. 1/2 plus 1/2. So x to the first, right? And then 0 plus 1. B to the 1.
B is 0. No, because you add B.
You add them, right? So 0 plus 1 is 1.
So you just,
Or you could have just gone like this. B to the 0 power is 1. So b to the 1. Same thing. Good question. Okay, good questions. Okay, when you divide, you subtract. But first, we always take care of the powers being raised to another power. Look, isn't all this stuff to the -2? So we've got to distribute that -2 through to both of those. And we're raising powers to powers, so we multiply. X to the -4 over y to the -8, right? And then we flip anything with a negative exponent. So look, this is a negative exponent on bottom. I'm going to flip it, so it comes up to the top. This is a negative exponent. We're going to flip it, so it comes down. So on top, we have y to the +8. On bottom, we have x to the +4.
So if you have a negative on the bottom, you move to the
Yep, you just flip it over a fraction. So, ding, bring it to the top. Okay, last one. and I promise I'll let you work. Last one. The first thing we do before we start dividing and subtracting and all that kind of stuff, we have to raise all the powers to more powers. So on top, there's nothing more to do here. We have a 9, x to the negative 2, b to the 3. But on bottom, isn't both that stuff being raised to the second power?
Yeah.
So we have 2 squared, x squared, right? Everybody, don't forget to raise the 2 to the second power, and then we have b to the negative 5. Now from there, when you divide the same base, you subtract, but not with numbers, guys. Not with numbers. And 2 to the second power is 4. 9 fourths, does that simplify? And we don't subtract numbers, so we have a 9 and a 4. Then negative 2 minus 2.
0.
Nope. Negative 2 minus 2.
Negative 4.
Negative 4. And you always write it on top, guys, look. Does everybody get that? Then we're doing 3 minus negative 5.
Negative 8.
Nope. 3 minus negative 5.
Negative 2.
Nope.
8. What's that?
3 minus negative 5.
8.
8. So we have b to the 8. Is everybody good with that? Yes?
Yes.
Then we flip anything with a negative exponent. So I gotta grab that, flip it to the bottom, x to the positive 4. So the pretty answer will be 9b to the 8 over 4x to the 4. Okay guys, properties of exponents. The first thing we always take care of is powers being raised to more powers. So ready, set, go. So scientific notation, if you had this decimal, for example, 0.0000257, if that was your answer and it said write it in scientific notation, this answer is not acceptable. You have to move the decimal and write it in scientific notation. So I actually am going to, you'll move it. So we're going to move it back 1, back 2, back 3, back 4, back 5. Now you know how I said to go to 2 places? I'm changing my mind because I started thinking about it. And that's actually, the most simplified is after 1 decimal. Does that make sense? So it's more simplified to stop the decimal right here. So in this example, we would have 2.57 and then times 10 raised to the negative. We moved it 1, 2, 3, 4, and 5. So negative 5. So everybody look at number 10. We have 38.6772 times 10 to the negative 2. Right, everybody?
Yeah.
Now, like I said, scientific notation, technically, I started thinking about it, is after 1 decimal place. So on an end of level, they would fix this. That's not incorrect, that's correct, it's just not simplified all the way. Don't we need to take the decimal and move it 1 place to the right? So that would be 3.86772. And since we moved it 1 place to the right, we added 1. So it should be times 10 to the negative 1. So I want you to write it like that, just for practice. But on an end of level, I would have accepted this answer. But the reason I show you this is because technically, scientific notation simplified after 1 decimal place. I would accept this answer on our final. That answer would have been okay. But I'm showing you because you might see it differently on a multiple choice thing. Does that make sense, everybody? Okay. Like problem number 3, very similar on page 2. So everybody look, that's a huge problem. We've got to work from the inside out. So first of all, I'm just going to focus on this piece, and I'm going to simplify it. Now we always look for powers being raised to other powers. So in the parentheses, I have a 7x to the 6, raise the power to a power and you multiply, and then y to the 3rd. Do you all understand how I have that on top now? Now on bottom, I'm going to simplify all powers being raised to powers. So it looks like we're going to have a 7x and then y to the 6, right?
Right.
And it's all raised to the 3rd power. So there's like 10 different ways we could do this. I'm just going to raise each of those to the 3rd power. So I have on top 7 to the 3rd, I have x to the 18, raise the power to the power and you multiply, y to the 9. Then on bottom, I have 7 to the 3rd. third, and a y to the 18. And then I'll simplify it. 7 to the third divided by 7 to the third. You could do it in your calculator, but that one did happen to divide out to be 1, right? 7 to the third is a number divided by 7 to the third. So then we have 18 minus 3. X to the 15 on top, and then 9 minus 18. Y to the negative. And then we would flip anything with a negative exponent. So x to the 15 was on top, and then y to the positive 9 on bottom. Now that fraction doesn't simplify. I mean, you'll type it into your calculator on number 3, and you should get 16 over 81. Okay, problem number one on the exam. We have 6 to the negative 1, 4 to the negative 2. Now you need to figure these out individually and then multiply them together. So 6 to the negative 1, if you type it into your calculator, you get 1/6. And then 4 to the negative 2, you type it into your calculator and you get 1/16. So if you multiply those together in your calculator, you get 1 over 96. In number 2, you have x to the negative 6 raised to the negative 3. We're raising this power to another power. And when you do that, raise a power to a power, you multiply the powers. Negative 6 times negative 3 is positive 18. Then in number 3, we have all the stuff being multiplied. I always simplify it in parentheses first if possible. So nothing we can simplify here, nothing we can simplify here. So we have 2x to the 4th times by 8x to the 15th. Because it's multiplication, we can reorder it in any order. So I'm going to put 2 times 8 by each other, x to the 4th times x to the 15th by each other. And I'm going to simplify it in pieces. 2 times 8 is 16, and then we're multiplying the same base here, so we add our exponents, and so we get x to the positive 19. And this would be our final answer. On number 4, we have all this stuff here. We've got to simplify parentheses first. Now looking in here, there's nothing we can simplify, so we have x, y to the negative 6. But looking inside these parentheses, we're raising all of that to the third power. So we've got to make sure to raise both of those things to the third power. So we have an x to the third, y to the third. Then from there, we can reorder in any order. So we have x times x to the third times y to the negative 6 times y to the third. And then you'll simplify it in pieces. So we're multiplying the same base, so we add our exponents. There's a 1 in there, so that's x to the 4th. Then right here, you're multiplying the same base, so you add your exponents. We have y to the negative 3. So then we would flip anything with a negative exponent. Our final answer, x to the positive 4 stays on top, y to the positive 3 on bottom. We flip it over a fraction to make it a positive exponent. Once again, from here, this doesn't simplify any further. So we have a to the 1/4, b to the 0, and then we have this piece doesn't simplify any further, a to the 5/8. Now I can reorder it, so I have a to the 1/4, a to the 5/8, and then we have b to the 0. So then we go ahead and simplify each piece. So we have this piece right here becomes, we're multiplying the same base, so we add our exponents. If you add those up in your calculator, change it back to a fraction, you have a to the 7/8, and then b to the 0 becomes a 1. Now make sure the whole thing becomes a 1, not just the exponent. So that times 1 is just itself. So I'm going to erase that because really we don't write the 1 in there. I mean, it wouldn't be incorrect, but it's more correct to just say we know 1 times anything is just itself. Okay, let's simplify this piece by piece. All of that inside there is being raised to the 1/2 power. Raise the power to a power and you multiply. So we have 4, and then 2 times 1/2 is 1. If you don't believe me, type it into your calculator. I've got to simplify this piece first. Don't forget to raise both those things to the third power. So we're going to have a 5 to the third and an x to the multiply, right? Raise the power to a power and you multiply, so x to the 6. Now if you type it into your calculator, you have 4 times 125. 5 to the third is 125, x to the 6. 4 times 125 is 500, so 500 x to the 6. Okay, number 7. Simplify in your parentheses first. Nothing we can simplify in there, so 7x to the 4th. Nothing we can simplify in there, so 5x to the 7th. So now I can reorder it. 7 times 5, x to the 4th, x to the 7th. So then multiply those two things together, 35. We're multiplying the same base, so we add our exponents, and that's 11. Simplify in parentheses first, so we have a to the 3rd. Do not forget to raise a to the 3rd power. We have x to the 1/3 times 3. Raise the power to a power, and you multiply, you get 1. All that stuff's being raised to the 2nd power, so we're going to put that -2 to both of those. So we have 3 to the -2, and then we have x to the, raise the power to a power, and you multiply. X to the 0 times -2 is 0. So I can reorder it. We have 8 to the 3rd, 3 to the -2, x to the 1st, x to the 0. Make sure you type it into your calculator correctly. So you have 8 to the 3rd power is 512. So we have 512. 3 to the -2 power is 1/9. So we have 512 times 1/9, and then we're multiplying the same base, so we add our exponents. 1 plus 0 is 1. So we have x to the 1. So now if you multiply it all together, you multiply straight across. We're going to have a 512 on top and an x to the 1st power on top, and on bottom we have our 9. So this would be our final answer. Now you could just type it into your calculator. 512 times 1/9, change it back to a fraction, you get 512 over 9. And then the x is on top, because it was x to the +1. Alright, so we simplify in our parentheses first. Nothing to simplify in here, and nothing to simplify in here. So we have a to the 0, b to the -2. I can reorder it. A times a to the 0 times b to the 3rd times b to the -2. Once again, with multiplication, you can reorder it. When you multiply the same base, you add your exponents, and that's a 1. 1 plus 0 is 1. And then 3 plus -2. When you multiply the same base, you add your exponents, so b to the +1. A to the 1 is A, B to the 1 is B. So our final answer is AB. On to page 2. So it says simplify. So we have 4/3 over 4 squared. Well, because they're the same base, we're going to subtract our exponents, and we always subtract the top from the bottom. 4 and then 3 minus 2, that is 4 to the 1st, which is equal to 4. Okay, also you could have typed it into your calculator. You could have literally done 4 to the 3rd power, which is 4 times 4 times 4 divided by 4 squared, and you would have hit math, enter, enter, and it would have simplified to be 4 if you would have typed this into your calculator. Okay, this next one, we have 5a cubed b squared divided by ab. When you divide the same base, you subtract your exponents, and you always subtract the top from the bottom. So we have our 5, nothing to do with 5, so we have a to the 3 minus 1. There's a 1 on that a, so 3 minus 1, and there's a 1 on that b, so we're doing 2 minus 1. So then we go ahead and do that. So we have a 5a squared and a b to the 1st. On top, nothing to flip over a fraction, so our final answer is 5a squared b. Okay, this next one's kind of a beast. You kind of want to work yourself inside out. So the first thing I always simplify is my powers being raised to a power. And I'm going to do that on the inside first. So I'm going to simplify that piece and that piece because all that stuff's being raised to a power. So I'm going to go ahead and rewrite the top. We have a 42, and then we have a to the 8, raise power to a power, and you multiply b squared. That's on top. And on bottom we have 63, we have an a. I'm going to put a 1 because there is a 1 power there. And then this becomes b to the 6. Raise a power to a power, and you multiply. Now don't forget, all that stuff's being raised to the 4th power. Now there's a couple different ways you can do this one. You can either simplify the inside first and then raise it to the 4th power, or raise all of it to the 4th power and then simplify. So I'm actually going to just raise all of them. Well, it's actually easier for me personally to simplify the inside first. So I go ahead and take my calculator and I type in, I'm just going to simplify inside first. So I am simplifying all this stuff first, and then my final answer, I'll raise it to the 4th power. You could do it many different ways, but I just think that's going to be probably the easiest. So I do 42 divided by 63. I change it back to a fraction, and I get 2/3. So we have a 2 and a 3 on bottom. Now with this, we're going to have the same base. We subtract our exponents, the top from the bottom. So a to the 7th. 8 minus 1 is 7. And then we do b to the 2 minus 6, so b to the negative 4. So I'm going to, 2 minus 6 is negative 4. I'm going to rewrite that by flipping that over a fraction. So we had a to the 7th, b to the negative 4. I'm going to bring the b to the bottom so that it's positive 4. So is everybody hopefully is good up to there? Now don't forget, that was all being raised to the 4th power. So I went and simplified the whole inside, and now I'm going to raise all of that to the 4th power. So don't forget to distribute the 4th through to every single piece. So we have 2 to the 4th on top, and a to the, and it was 7 times 4, which is 28. And then we have to do 4 to the 3rd power on bottom, 3 to the 4th power on bottom is what I meant to say, and then b to the 16th power. Now you'll type it into your calculator, 2 to the 4th, we have a 16 on top, we have our a to the 28th still, and on bottom you'll do 3 to the 4th power, 3 raised to the 4th power, which is 81. We have an 81 on bottom and a b to the 16th. So this would be our final answer. Probably one of the harder ones on there. Number 4. Okay, first thing I always do is take care of any powers being raised to powers. We're raising all that stuff on the inside to the 4th power. Raise a power to a power and you multiply. So you're doing 1/4 times 4, which is 1. And then we have y to the 1/2 times 4. Raise a power to a power and you multiply. So 1/2 times 4 is y to the 2nd power. So our final answer is x over y squared. Alright, once again, the first thing I take care of is my powers being raised to more powers. So I'll rewrite this. This is 3 to the negative 2, a to the negative 4. You've got to distribute that through to both. And then you'll have on bottom an 7 to the negative 2 and an a to the negative 10. So you've got to put it through to all of those. So then from there, I'm going to flip all negative exponents. So really, we're going to take this and flip it. We're going to take this and flip it. We're going to take this and flip it, take this and flip it. So we're flipping all this stuff over a fraction. So our 3 squared comes to the bottom and becomes positive. Our a to the negative 4 comes to the bottom and becomes positive 4. My 7 squared goes to the top because we're flipping it over a fraction. So now it's not a negative exponent anymore because we flipped it over a fraction by taking it up there. And we're going to take this and flip it over a fraction, so now it's a to the positive 10. And now I can go ahead and simplify this. So I'm going to just do it piece by piece. So 7 squared is 49, and then 3 squared is 9, and then a to the 10th divided by a to the 4th. Look, we have the same base, and when you have the same base and you divide, you subtract your exponents, the top from the bottom. 10 minus 4 is 6, so a to the 6th. Now I'm going to check in my calculator, 49 divided by 9. I change it back to a fraction, and you get 49 over 9. So that didn't simplify any further. There's my final answer. Okay, let's simplify this one in pieces. So the top doesn't have anything to simplify. We have 3a to the negative 2, b to the 4th. Nothing simplified. The bottom, though, it does simplify. Look at that piece. All of that stuff is being raised to the 3rd power. So that's being raised to the 3rd power, and so is that. So we have 2 to the 3rd, a to the 3rd, and now b squared. And now we can go ahead and simplify. So we have a, let's see here. So we have a 3 on top. I'm actually going to go like this. A to the negative 2. I'm going to do all my steps here. 2 to the 3rd power is 2 times 2 times 2, which is 8. Now we have a to the 3rd, b to the 2nd. Okay, so now we're going to focus on it in pieces. That doesn't simplify. 8 over 3. If you don't know, you'll type it into your calculator. So we have a 3 left and 8 left. Nothing simplified further. Now when we have the same base and we take our x and they're being divided, we take our exponents and subtract. And you always subtract the top from the bottom. Negative 2 minus 3. And then when we divide the same base, we subtract and always the top from the bottom. So we're doing a to the 4 minus 2. Okay, let's give myself some room to keep simplifying this. So we have a 3 on top, an 8 on bottom, and then negative 2 minus 3. is negative 5. If you don't know that, just type it into your calculator. Negative 2 minus 3. You get negative 5. And then you have a b. Oh, this was a b. Sorry, this was a b. So then we have b to the 4 minus 2 is 2. So then from there, our last step would be to fix any negative exponents. Only this has a negative exponent, so we flip it over a fraction. So on top, we have a 3 and a b squared. We had a 3 and a b squared left, right? And then on bottom, we have an 8, and now an a to the positive 5. So we have an 8 and an a to the positive 5. And that's as simplified as it gets. All right, the fourth root of 625. You can do this a couple different ways. You can either do it in your calculator or by hand. So I just typed it into my calculator. You type it in. You have to type a 4 and then hit the math key. And then scroll down to the xth root and then type in 625 and it'll give you the right answer. Or you can do it by hand. 5 times 125. 125 breaks down further. 5 times 25, and then 25 breaks down into 5 and 5. And because it's a fourth root, we pull off roots of 4. So there's 4 5s that can leave the house, and nothing was left underneath. So our final answer was 5. Okay, let's look at this one. We're going to simplify it first. Simplify the parentheses. Nothing to simplify there, so we have d to the 1/3. We have all that stuff, and it's all being raised to that power. Raise a power to a power, and you multiply. So 2/3 times 1/4. Then you get 1/6. Yep, 1/6. So we have a to the 1/6. And then this, we raise a power to a power and we multiply. So there's a 1. 1 times 2/3 is d to the 2/3. Now from there we can reorder it. D to the 1/3, d to the 2/3, d to the 2/3, and then a to the 1/6. So then from there, we're multiplying the same base, so we add our exponents. 1/3 plus 2/3. Do it in your calculator if you must. 1/3 plus 2/3 is 3/3, which is 1. So we have d to the first power, and then we have a to the 1/6 power. Now from there, we can't combine those two things, but now we're going to rewrite it in radical form. So d to the first power cannot be rewritten in radical form. But we can rewrite 1/6 as a radical. Remember, roots are on bottom of our flower. Roots are on bottom, and the power comes from the top. So we have d times 5, the 6th root of d, or of a, wait, let's see, it was an a, sorry, a to the first power. So the 6th root of a to the first power. So that would be our final answer. Now obviously, I mean, if we wanted to get technical, we would write it even prettier. D, 6th root of a, because a to the first power is a. We don't need to write the times sign, because this is what it would, I guess, technically look like if we wanted to simplify it all the way. Okay, next one, simplify the in groups first. Nothing to simplify there, so we have 5x to the 1/3. We have nothing to simplify here, so we have 10x to the 3rd. Now we can reorder it. 5 times 10 times x to the 1/3 times x to the 3rd. 5 times 10 is 50, and then when you multiply the same base, you add your exponents. Do it in your calculator, and you get 10/3. So then from there, we can rewrite it in radical form. Remember that only this piece is being raised to the 10/3 power. So that's the only piece under the root. If there was some parentheses here around the 50, we would know they are both under the root, but they're not. So this is 50 times 5, the cube root of x to the 10th power. That's rewriting it in radical form. And that's all for the video. Now, I guess I'll do number 10 real quick. It wants us to prove that the 4th root of a to the 6th is equal to the square root of a to the 3rd. So what I'm going to do is say, okay, I know that radicals can be rewritten as rational exponents. So I'm going to rewrite this as rational exponents, which means fractional exponents. So we have a to the roots are on bottom, so it's 4 on bottom and then 6 on top. That's equal to And we have a square root on bottom. This is a 2, but it goes without being said the 2's there, and a 3 on top. Well, take your calculator and simplify 6 divided by 4. That simplifies to be 3/2. So we have 8 to the 3/2 is equal to 8 to the 3/2. And you proved that those two things are equal. You just had this was not simplified all the way. So this side just simply wasn't simplified. So I rewrote them as fractional exponents, and then I just made sure they were both simplified all the way, and they did come out to be equal. That's the end of the video for pages 1 and 2. There will be another video for pages 3 and 4.